This is the solution to written homework 35. So find and classify all stationary points. So the first order of business is to find the stationary points. So the x partial is 21x squared minus 126y. The y partial is 6y minus 126x, and we want to solve that these are 0 at the same time. So 21 x squared minus 126y is equal to 0 at the same time as 6y minus 126x is 0. So then I'll use the second equation. Uh, 6y minus 126x equal to 0. So 6y is equal 126x. And 126 over 6 is 21. So y is 21x. Now I'll take that and plug it into the first equation. So that will be 21x squared minus 126y is equal to 0. And I'm going to take this 21x and put it in for that y. So then 21 x squared minus 126 times 21x is 0. So now, among these terms, I see that 21 and x are common. So 21x multiplied by x minus 126 is 0. So x is 0, or x is 126. Now we can figure out the y's corresponding to these by plugging them into here. So then plugging in x equal to 0 into that yields y is 0. So specifically taking this information, plugging it into there. So we get y is 0 for that one. And then 21 times 126 is 2646. So y is 2646. So the two stationary points that we found are 0, 0, and 126, 2646. So we found the stationary points, and now let's classify them. Now to classify them, we'll use the second partials, so I'll find the second partials. So the x partial is 42x. The xy partial, so the xy partial is the y partial of the x partial. So y of x is negative 126. The yx partial is the x partial of the y partial, so negative 126. So that's good. The two mixed partials are equal. So the y partial. So the y partial of the y partial is 6. So now we're going to classify point 0, 0. The classifier there, so xx at 0 is 0, yy at 0 is 6, minus xy at 0 is negative 126, and then square that. So that's 0 minus something squared, so that's negative. And therefore the conclusion is that 0, 0 is a saddle. Okay, so that's a saddle point. Now let's classify point 126, 2646. So the classifier there. So 42 times x should be twice that number. 5292. So that's xx, yy, so that's 6, and then minus xy, so negative 126 squared. Plugging that into the calculator, we get a large positive number, 15,000, or almost 16,000. So it's positive. So D being positive means that the concavity is consistent. So it's either always up or always down. So let's measure the concavity in the XX direction at 126, 2646. And when we do that, we get this number. So that's 5292, which is positive. So D being positive means the concavity is consistent, and in this direction it's positive, so it's positive in all directions. And therefore the point 126, 2646 is a local min. Positive in all directions. And that's the solution to the exercise.